the caliber of that extreme, but we do use certain chemicals that give us the propulsion that just solid, like your SDs, rocket boosters.
A lot more complicated than bottle rockets, in other words.
A little bit.
Yeah.
A little bit bigger.
Them
a little bigger.
What is it? Solid. What is that fuel called again? Yeah,
What?
it's like solid booster rocket fuel.
Yeah, it's just solid rocket fuel.
Yeah, they didn't put that in my bottle rockets as a kid. That's what I'm saying.
Right. No.
It could just be like water and like pressure. Then
Sometimes soda.
Soda.
And Mentos.
Fun to clean up.
Yeah, that's true. Anyways, we're going to get into our discussion of space exploration in a minute, but before we do, we just like to set the mood with a little song. So please stay tuned, everyone, and we'll be back in a moment.
Keep it locked.
90.5 WVUM, the University of Miami.
What's going on?
And as we said before, we are joined by Sean McDuffie of SEDS, and we were just getting on to our conversation about space exploration. Now, we were talking a bit earlier about why people should care about this. And I'm going to stop for a moment and play devil's advocate and just... Okay, let's say I don't believe that investing anything in space is worthwhile. Let's just say that I'm just perfectly fine with being on Earth and with not really knowing about anything else in the universe. What would you say?
Sure.
Yeah. I'll let you.
I think that you're playing devil's advocate, but I'll point out that there's a lot of people that think that without playing devil's advocate. And I'd point out that space has given us a lot, and it's trickled down into our everyday lives, everything from your cell phones to the bed you sleep on. The problem that people see, I think, with space is that when you try to put money towards something, you want to ask them, what am I going to get from this, right? What is this money going towards? And when we say space exploration, they go, okay, we're just paying you to go do what? And so it's a little bit of a leap of faith, but if we take history, the history of our space exploration and space science and space program, we see that the money that we've put towards NASA and towards space exploration has more than paid itself back in the amount of things that it's given back to our society. Your cell phone, cellular connectivity, satellites, global monitoring, the weapons that the Department of Defense has, all of these things are very much contributed to NASA, even down to daily life. I mentioned your mattress earlier. A Tempur-Pedic mattress, that was actually started by NASA. They researched the material to...
Really?
Yeah, they researched Tempur-Pedic material
to
absorb impacts. Yeah, and
that's
so
pretty cool.
someone thought it might be a good idea, and it turned into a common everyday item that now Serena Williams endorses. So, we've got things like that.
Yeah, and microwaves too. Don't forget that.
Absolutely, yeah.
I'd ask the devil's advocate, have you microwaved things recently?
Mm-hmm. Yeah. And I
Wouldn't really go anywhere, but just be fun.
There's a lot of things like that.
I don't believe in microwaves.
that people forget, and it's easy to, I use my phone every day, and every time I use it, I don't thank the satellite that it goes up to and back. But there's so much that we get from space exploration because we have to create. We were talking a little bit earlier about, Kennedy's famous moon speech and how, we'll build a large rocket and develop materials that we haven't built yet. And in that speech, he admits that we're going to need to do things that we don't know and haven't found or made yet. And that's the beauty of space exploration, is that the climbing and overcoming these massive goals creates this need, and creates this desire to be able to do this and create these things and mindsets that solve these problems. Necessity is the mother of invention, and space is a brutal place out there, and there's a lot of necessities out there. And so when we go out there and when we landed on the moon, when we decided to explore what was in lower and upper Earth orbit and finally land on the moon, when we had to overcome the obstacles that those threw at us, we came back with so many things that have just improved daily life for everybody else on Earth.
Yeah, and I'm gonna say I personally enjoy that trek where you don't know exactly the kind of problems that you're gonna run into or how to solve them, and I'm totally proud of all the things that we have solved. One of the next ones that we should solve, though, I'm wondering, do you have any information on the dangers of of radiation that goes through shuttles and stuff. I mean, has there been work on that recently you've heard of? And
Like dangers for the astronauts or
for the
personnel?
astronauts,
Right.
of course.
Yeah, that's a very big topic of study because our atmosphere protects us very much from sun radiation. And that's one of the problems with inhabiting another world or even a moon, is that even on Mars there's very little atmosphere to protect us from UV radiation. It is a very big portion of their what they account for, like on the ISS, making sure that it's insulated from radiation so that they don't come back with radiation poisoning or anything like that.
See, that's some totally useful and amazing stuff that we could use right now. I mean, I know that one of the biggest fears, for example, with nuclear energy, right, is the concept that it's not clean. Well, the only way that it isn't clean is if it escapes a facility, if somehow there's a meltdown. And we've seen what happened, we've seen what happened with Fukushima and stuff like this. And if we had materials or better, ways of dealing with escape radiation and things like this, maybe we could convince ourselves, we can know that it is clean energy at this point. Solution that is infallible or something close to it. That'd be a huge step.
Right. And you
forward.
mentioned Mars, and we were talking about this as well earlier, that in the course of our exploration of space, this is probably the next milestone. Is that right?
I would say that's the next big thing that the public has its eye on, I think.
Yeah, that's what they want to.
Absolutely, yeah. That's like, put a man on Mars. It's got that same flashy tagline as putting a man on Moose.
Right.
And putting a man on the moon.
On the moose, yeah. It's
on
been
the
done
moon.
since Bullwinkle, right?
Do you think there's the same excitement over it, though, as there was in the 60s, maybe?
I think there can be. At the moment, obviously not. In the 60s and under Kennedy administration and the Johnson administration, we had the nation at our back. And there was a big push towards that. And, America, you think about America settled around their TVs watching the rockets go up. But I've done some reading on those missions too. And the sad thing is the Apollo program actually lost a little bit of its flair after about Apollo 12-ish.
Right.
They landed on the moon and okay, we went again. And obviously there was a lot of science that we picked up. But it did lose a little bit of that first time that we landed. But I think that Mars is that next big thing. I think NASA does a lot of huge things for space exploration, though, and
Right.
for life. I think that if you're looking for life or want to study possible life, Mars really isn't the optimal place for it. NASA
can
had
imagine.
what was that?
Yeah, I can imagine. But
Right.
Mhm.
And you were mentioning the motivation, but I guess part of the motivation as well in the 60s was also the ongoing Cold War. Because years ahead of, before man was on the moon, Sputnik, the first satellite, was launched into space, and that was a huge milestone for the Russians.
Well, politically,
Right,
remember, because
politically.
it was just
So I think it also has to
metallic
do with
sphere
it,
that
though.
did nothing.
Right.
Absolutely.
Like, aside from the basic need right now for Mars of just curiosity, what's the extra motivation?
Sure. You're right. Back then, Russia beat us to two major milestones. They had the first satellite in space, and they also put the first human in orbit, Yuri Gagarin. And, that really scared us and got us into doing the things that we need to do. But I think you need to, we're very lucky to have this planet, and I think that view that you mentioned earlier about, we're here, we need to make the best of this planet, and that's very true. And this planet has given us a lot, and we should value that and improve that, but also recognize that this planet has a history of being very harsh to its inhabitants as well. There have been 5 known massive extinctions, and we're arguably in our 6th right now, and there is nothing there's nothing by the laws of physics or anything that prevents us from being one of those species that gets wiped out.
Absolutely. Yeah.
Right.
Yeah, and if you think about this planet as a hard drive, it has been great for storing information, and we'd like to keep it that way. But that hard drive has a tendency to crash, and so if we can put out other hard drives, so we can get Mars to be another hard drive, if we can get other planets and other solar systems to be a hard drive outside of our lifetimes, we can keep our human society and race and knowledge that we breed to grow and expand.
Right.
Yeah, I share that view, and I want to bring up those who feel that maybe the best way to solve these issues is, instead of finding new hard drives, in your analogy, to figure out how to upkeep this particular one. Throughout all my limited studies to this point, it seems like an impossibly harder problem to figure out how to politically and socially manage our own planet, as it is to at least have a backup plan. To find a backup plan. I think it's simpler.
Yeah, and
we might as well do that.
Right, and I agree with you to a certain extent, because I do have one disagreement with that, in that I think there's a little bit of a human nature that kicks in when you leave somewhere. And what I mean is like Andy, where are you from?
I'm from here,
You're
from Miami.
From Miami, okay. Where are you from, Israel?
I'm from Venezuela.
From Venezuela. Okay, I noticed neither of you guys said you're from Earth. Right? Okay.
Well, that's
so
inherent.
you're right, exactly. It's inherent.
Right.
But
You
when
tricked me.
Exactly, but when you leave Earth and you have a civilization or anything that's not on Earth anymore, all of a sudden that becomes something, Now you're not from here and you're not from Venezuela, you're both from Earth. And that's a unifying factor, and that is something that pulls a society together, is superordinate goals, right? And so once you get a society to recognize you're all from the same place, you're all in this uninhabited space area, and you're on this very lucky little globe that has the ability to hold life, when you recognize that, you all of a sudden, this rush happens, like, holy crap, we gotta, make sure this planet stays alive, and we gotta make sure all these petty little squabbles that happen between countries and people, can be stomped out by recognizing that you're all from the same place, in space.
That I feel that.
Right.
Okay. It's a tough one. It's a
Right.
tough.
Looking at the bigger picture just makes everything going on in the world and politics look very petty. That's what you're trying to say, right?
I mean, that was a little pointed, but yes.
Right.
I think that, looking at the infinite picture, that
Right.
that we are all on this planet together. And I think what you mentioned earlier, that it's very hard to think about the upkeep and being able to bring this planet back to what it can. But the mentality that is needed to do that, I think you can gain when you leave.
Yeah.
Right.
That's one of the things that I love about the technological progress that we made in this country, because that exact feeling that you're describing, I've had walking out of an Avengers movie, or certain really, really good movies that were just so well made, and you sit there in awe. And it's not just movies, you can get this from performances of all kinds.
Literature, sure.
I mean, that's the importance of the arts, one would argue. I guess I'm arguing that, right? But my question to you is, on that place where I'm like, okay, I'm not from Miami, I'm from Earth. Is there a Seminole there? Is there an FSU fan? Because then that would really take me back to the whole Miami thing,
right? And yes, the point is driven so far. You have the rivaling villages, and my high school had a rival school across town and things like that.
Like,
and
we're still gonna have those rival schools,
right?
It'd be
exactly.
Like, we're East Mars, man. Like, what do you think?
Exactly, and you're totally right. But even the tone that you're taking right now shows how that changes, right? And it's no longer a true rivalry. It's something that you maintain to better yourself. We want to be better than them. We want to be better than us right now. To improve ourselves, because we should do this to beat our rivals. And it becomes something more of that than it's just a rivalry because we need to
better than who you were yesterday.
Right, exactly. Better than you were yesterday, but with the intent of being better, not with the intent of extinguishing the other person.
Yeah.
Right.
See, that's.
I guess that also that reminds me of the approach that I mentioned off show.
Sure.
Of Elon Musk, how, in regards to Mars,
yes,
he proposes that the only way to make it habitable to any life on Earth would be to use thermonuclear weapons to launch at the polar ice caps at Mars in order to release CO2 and subsequently warm up the planet to make it habitable for humans. And you were saying that that's not so much the approach of an explorer, but more of a conqueror.
Yeah, I mean, to a certain extent, because how I mentioned that was that if there were people on Mars, if there were humanoid organisms, right, and say they were able to live there, but we weren't. I would hope that in our today's society we wouldn't say, well, we can live there, so let's send a nuclear weapon to their planet and blow up their ice caps and ruin their land, right? Exactly. So even the fact that you said what, but what if those life organisms aren't humanoid? What if they're just beginning in their life cycles? Just growing their life tree. They're still at the very trunk of it. They're only they're secluded to underground or in the very small amounts
just
of water.
Organisms.
Exactly. Just
small,
just
bacteria
or
exactly. So where do you draw the line at? We are messing with another living species or organisms or territory, right? We need to be careful about those things, and I think that's where space can be definitely much more of like an engineering project, and there's a lot of ethics that go into it. And I think while we can warm up ice caps and bring CO2 into the atmosphere, start trapping some heat and building UV protection, we haven't even put someone there to see if there's life, before we start ruining a planet that might be habitable for a different life foundation, right? Because we tend to assume that we're the only living things and we're the only things that can live, but really life is just something that has been naturally selected for in your environment that continues to propagate, right? And so if there's something there's something that
description of it, yeah.
Exactly. So if there's something that is able to do that in that environment, then who are we to really go and mess it all up by sending a nuke there?
Well, at the very least, ignorant. Because what we can learn from seeing that an organism has existed for some period of time on Mars, let's just say, or anywhere. I mean, if we could see what has been working there, we can learn about so many things that here at home might help us. The concept of a cell that could survive in such conditions, maybe could teach us about more of the cellular. The structure, something that could be maybe an improvement to certain medical techniques that we have now.
Absolutely. And that brings us back to rivalry, right? When you compare, you look at how something else has done it, and you look at, can I do it better? Winston Churchill said, to improve is to change, and to perfect is to change often. So if we can look at different perspectives at how possibility of life performs elsewhere, we can improve ours.
I absolutely agree. And yeah, you can't do that if you nuke the thing.
Right.
Not sure how we got here, though.
Yeah. We're about to talk about... actually, I think it'd be interesting to talk about how we'd go about sending a human to Mars, because obviously a lot of people see that as a lofty goal, and there are a lot of parameters that many argue that we have not been able to achieve. But before we do that, we're actually going to go to another song here, so please stay tuned, everyone.
And before we go, let's give you that number one time so you could text in, give us your thoughts on space. That's 786-309-88... whoops. What is that?
8861, yeah.
Yeah, that's 786-309-8861.
And we'll be right back.
Keep it locked.
This is Navy Roy Freeland. WVUM is turning on. Become a part of it and support your radio station.
And welcome back to the Monkey House, everyone. That was Space Chunk Galaxy from Super Mario Galaxy. Honestly, I couldn't think of a more fitting type of song to put in this discussion. And welcome back. I'm Israel.
And I'm Andy.
And we are joined by Sean McDuffie of SEDS.
In the Monkey House.
Thank you for that.
Welcome, people.
And right now we're going to talk about... Woo! Thank you for that. What it would take to explore Mars, because obviously there are a lot of... I feel barriers that would prevent us from being able to send a person to Mars without it being a one trip mission. So, what do you think? Do you think we're at that point yet?
Yeah. I think we can be, and there are some barriers that you mentioned. There's some barriers like you mentioned that a big one is our orbits.
Right.
Earth and Mars are not able to be, at this current point in our technology, are not able to be transversed at all times. If you were able to organize a round-trip mission to Mars, it'd be about 3 years, because when we get you there, we need to have the planets lined up properly, and when we get back, we need to have that same or similar alignment. And so between those two, it's about 3 years when we can get people there and back. So resources and things is a big issue. That's why if you look at like Elon Musk's Mars mission plan, it is prefaced with some unmanned missions first. Need resources down there, get things set up, and then put people down there.
There's also the approach NASA is taking with like the Curiosity rover as well.
Yeah, Curiosity, and it's funny, when you mentioned this earlier, but at this current moment, Mars is, if there's no life on Mars, Mars is completely populated by robots. It has Curiosity and the satellites that are above it. But putting someone there is definitely, like you said, a very large goal. We have, that's what SpaceX is trying to do, and that's what NASA is trying to do with their new SLS, the Space Launch System. They're putting rockets together, and the only thing holding us back at this point is funding and time. Give us time, give us money, and we'll make it happen. That's why I love space. Is what we've always done. And even in drawing back to the '60s, we didn't even ask for time. We just asked for support. Said we will go to the moon and do the other things before this decade is out.
Right.
And that was a bold claim, and I think that is also
awesome.
an inspiring. To get a little bit off topic, that is an inspiring part of space to me. Is that we aren't doing something that we know we can do. We said that looks cool. That would be amazing if we could do it. Let's figure out how to get it done, and let's figure out what problems are going to lie in our wake, and figure out a way to get over those.
Yeah, and
like
go
since
for it.
we can, we should. In other words,
Absolutely, and that's
Since we might as well.
that's a better way to put it. Yeah.
Exactly, and that's human. That's the human condition right there. Why?
Manifest
I really
destiny.
love that speech. Why climb the highest mountain? Why sail the Atlantic? Because we can. Why did we set out? Why did Christopher Columbus set out on an ocean that was thought to be flat and his ship could fall off the sea? Well, when he did that, we learned that this isn't true. There's a whole other piece of land there that we can live at, and that's what we do as humans, right? We're not very complacent as a whole. We like to explore, and that's the next piece. And the goals that we have are in direct correlation to what the moon was back in the 60s. You know, people had thought, well, we can't put a moon, we can't put a man on the moon. There's, you know, it's too far, it's too hard, it's too dangerous.
Yeah, I really like thinking about that, actually. I want to take a second there because I've considered, you know, at different times how cool it must have been, you know, to be part of the program and to be part of the population that was watching this moon launch emerge and actually work, you know. And is that what this kind of is right now? You know, we just don't feel like it is because we're here. You know,
I
you
guess.
think that maybe
Mars
is the next moon.
I think we have pretty good reasons to be paranoid. In the late 80s, there was that one rocket that, I forget the name, that one rocket that burst and 5 astronauts were killed. I don't know if you guys remember that.
Well, I mean,
you're talking about Challenger. I mean, listen,
Challenger.
There's a lot that have, even the Apollo missions,
Right. I recall there was a story that it almost crashed into the moon. Is that the story, or
yeah? So
really?
Apollo 13 had a really scary couple days. An oxygen tank in the ship had burst, and they lost a lot of their oxygen, which was their which was their oxygen life support, but also provided their electricity too. It was it reacted in electrochemical cells to provide electricity for the spaceship too. So that was a big problem. But pointing those out, you can't explore, you can't do those things without risks. And I think that's the issue, is that, you know, when you look at those tragic events, and yes, they do occur, and it's too naive to say that they won't. You know, we'll get to the Mars and we won't lose anybody. That's not true, you know, and I implore anybody that thinks that way to correct that, because you need to accept that when you do these things, that's what happens. And that saying goes, you know, the future's for the bold and the future's for the brave, and so is space. You know, it's very true. You know, it takes a certain
you know, you're gonna have fears all the time. We don't govern ourselves by the fears that we have. Yes, there have been failures. I mean, that's an obvious thing. You know, we've seen failures in many aspects. How many successes have there been, and what has come out of the successes? And has everyone that's been a part of it been on board, understanding what the consequences were? Yeah. There's a yes to every one of those concerns.
And what has come out of the failures too? You know, failure is it's funny. There's a show that me and my dad and my family used to watch a lot called Mythbusters.
So as basically everybody listening, I'm pretty sure you guys have watched it too. I've seen it.
But they have a tagline that failure is always an option, and it's a little bit crude to translate that when human lives are at stake. But the idea behind that being that when something fails or doesn't go right, you can't just put that on the shelf and say, well, that didn't work. You have to look at that. And failure is a great time to learn. And I think that with the failures that come from exploring space, that's when we learn about ourselves and our planet.
Yeah, and a question I like to ask is, what do you think those who didn't make it through the trials, do you think that they'd be happy if we stopped immediately upon their failure?
Absolutely not. Yeah, that response just about sums it up. These people died doing what they felt they were driven to do, and for that much, they deserve respect. And for that much, it's also not right to just stop the program entirely.
Yeah,
and I'm not at all saying that this fear of failure should be a driving force for us to not do anything at all. I'm just saying that this is a concern that the population actually has.
Okay, so you're...
Yeah,
right.
I'm not speaking for myself. I think that we should go, as you say, above and beyond, but that is always going to be one thing that stops us.
Yeah, absolutely. And I think, you know, you said you don't speak for yourself, and you don't have to. On that Apollo 13 mission, Jim Lovell was one of the astronauts on there, and on that mission, and after that explosion, they have microphones that transmit down to that are downlinked to NASA's control center, right? And they have different settings for these microphones. And basically, his microphone, he hadn't turned off the hot mic setting, which basically means anytime he starts talking, the microphone picks it up.
Oh yeah, we know what that means here.
And so he got he let a stray comment loose to one of his fellow astronauts about he was disappointed that he didn't think there'd be another moon mission because of the public opinion that this was going to grab. And
wow.
he's just around, he's going around the moon. He hasn't been returned safely yet. He knows his life hangs in the balance, and he's disappointed about the prospects of the future of the program and the mission at stake. And I think
back at the time when that was
that shows
happening,
exactly the mentality that I would hope that I hope and I think that those astronauts, everybody that's involved in this program, have, is that
you can be
they're
sure.
part of us. They're part of a bigger than themselves mission.
And they're definitely cognizant of that fact.
Absolutely.
Yeah.
Right.
I'm
I
with
recall reading from Andy Weir's The Martian that when the man who, spoiler alert, got stranded in Mars, he actually had to insulate himself in an environment of sorts that would allow him to survive. So I guess that had to be the approach for any man, or person rather, who'd want to go to Mars, right?
Wait, what is this from? This is from the...
A book.
Yeah, the book, and it's also a movie starring, what's his face? Matt Damon? Matt
Yep.
Damon.
Ha!
yeah.
Matt Damon.
I haven't seen the movie. I have read the book.
Smart
the book's
guy.
very good.
It's
But-
very good.
but-
It's fictions like these, like Martian and Martian Chronicles, that really kind of inspire me, and also other people to really think outside the box on this sort of thing, and think, you know what? If we really can explore space, we should. But sorry, that's a tangent. You were saying?
I don't remember what
We were talking about The Martian and how Matt Damon's character insulated himself in I remember I think it was a base of sorts where he was growing these vegetables.
Yeah, and that's the plan for if and when we get there. I mentioned this earlier, that I was reading an article that NASA scientists had written in the 60s, in the late 60s, that they had conceived of they had not conceived, that makes it sound like they thought it up. They had studied plants that they thought in conjunction might be able to tough the harsh terrains of Mars. One that they support each other in dealing with the two major hazards, and that those two are the temperature, the very low temperature and very high temperature fluctuations, and the UV radiation. And they showed that they might be able to get these two to work together, and that was in the 60s. From all of the technology and genetic engineering that has come since that time, if that's where we were at in the 60s, then I think we can, that's the plan for now, right? Is to get there and be able to grow and produce things that we can eat or start building an atmosphere.
Let me tell you, I've been surprised by the kind of progress that has been made since the 1800s. If you look at scientific progress and even mathematics that was formally developed and science that was thoroughly tested by just basically the 1880s, it's not too different from what we have today. Mm-hmm. The difference is that now we've really perfected the ability to measure certain quantities and things, temperatures and distances and crazy kinds of ways of measuring what we used to measure. And it doesn't surprise me that in the 1960s, that's what we're referring to. You're saying in the 1960s there was a research done for the possibility of growing plants.
Right. Yeah. They looked at the feasibility of withstanding the radiation that they've measured to be on Mars, and the temperature that they've measured to be on Mars.
Yeah, doesn't surprise me at all. That's it's pretty cool.
And it's actually interesting that you mention this rapid pace of technological progress, because that's actually what we're going to talk about right after this song. So please stay tuned, everyone. That's a good segue, right?
Yeah, man.
And we will be right back.
WVUM FM, Coral Gables, Florida. The voice of the University of Miami.
Andy.
And we're joined by Sean McDuffie, and we've got a lot of messages, actually. We couldn't see them earlier because the machine wasn't working, but it's glad to hear from a lot of you about what do you think about these discussions. Let's see.
Yeah, I'm glad you guys like the playlist and space. We're into space.
Yeah, we really appreciate it. And anyways, I was actually talking during the break about the sounds of Saturn because this is completely unrelated to what we're talking about. But to those of you who are unaware, the sounds of Saturn is essentially a clip recorded by NASA by a satellite, I believe, that picked up some really strange radio waves / emissions. And when they acquired these waves, they compressed it into a sound that humans can hear. And I'm just gonna play a little bit of it so you guys can hear it.
That should be cool.
that was a bit of that there. Somehow Saturn turned into an eldritch horror.
I mean, that's fitting for October,
right?
Considering that October has been taking over our themes and stuff. That's
right. And anyways, we were just talking before about the rapid pace of technological advancement, and I think that it'd be appropriate to perhaps discuss about how advanced technology has gone and how certain industries have been affected. For example, last week I was talking with the webmaster about self-driving cars. We were both arguing about the necessity of self-driving cars, or not arguing, rather, discussing.
Well, yeah, giving
and
arguments, yeah, of course.
And whether it would damage industries in a negative way, and we both kind of agreed that it would. But at the same time, it's hard to see why we would allow something like this that would displace so many workers. What do you think about that?
Well, displacing workers with
like, say, for example, cars? Uber drivers or taxi drivers or Lyft drivers would be displaced by self-driving cars, because then Uber companies won't have to hire anyone. They could just put their own self-driving cars on the road, and that's that.
Well, now that we're on this think tank mode, this is a fun one, because particularly in Miami, I can give you my opinion. I think we all know what it's like to deal with traffic here, and it's already dense enough as it is. Doesn't matter if you have a bunch of self-driving cars or not. Good luck getting them on the road. You'd have to get other people off the road if you want to have a successful self-driving situation, so you'd have to...
Although they have designed self-driving cars to make it so they could operate with other people on the road and not get into accidents, apparently.
Oh, well, I mean, they haven't encountered the occasional drunk uncle or whatever it is that happens out there. Look,
right.
Unless it's a flying car...
That happens with normal drivers, too.
The density of cars on the roads is already too high. It's not something that you could just, displace... unless it's so appealing, right, these self-driving cars, to be a part of the service and that it actually fixes transportation in some way, people won't opt to do that. And given the history of Miami alone, I don't think anyone's just going to trust that this new self-driving whatever is going to get them to work on any reliable time.
I think companies are going to adopt anything that helps them save money, and that's something that might. Who knows? But I mentioned the self-driving car as an example because it's only one of the many ways in which we see certain industries being threatened. And don't get me wrong, like, technological advancement displacing certain industries is a common thing. It's happened back in the day. We don't have blacksmiths anymore. We don't have certain...
Well, we do. I mean, you still have welders, for example. Welders will never go away.
There's a difference.
Of course, but it's not a necessity is what you're saying. Right? Mechanical engineers from a couple of years ago will tell you today that they feel exactly what you're talking about. That there's these machines that can properly do some of the most complex, machining tasks, and come up with parts that are of fantastic quality, such and such. But, will the amount of these machines and their availability outpace the workers who can do it manually anytime soon? No, but will it affect it overall? Yeah, of course.
What do you think about all this, Sean?
Yeah, I mean, the point that you brought up about, workers, I can see that. but they'll need upkeep, and that's something that we'll put in, do a small amount of replacement of those jobs. I think what you mentioned about companies doing things that will bring them a profit. I think on the surface level, it can seem like that self-driving car, we don't need to pay that driver anymore. But you do get a little bit of a harm in that public opinion. And so for however much you save on that driver, you lose, if you compare Lyft and Uber, say Uber beats Lyft to self-driving cars, people who don't really feel safe in a self-driving car, maybe they stop using Uber because they don't want the risk of being picked up by a self-driving car, And so I think that, those kind of companies aren't naive in thinking...
It's because it's not the norm yet, but who
Right.
knows? And there may come a point in which it will be.
Right, exactly.
Now,
And for some people, it's not really a matter of if, but when.
Exactly, and that's the thing is, like, if you look at the possibility, I know you kind of threw out flying cars about, that traffic density thing, but when you look at what does a flying car allow you to do? It allows you
to make up for the lack of wide roads in Miami to account for the traffic that we need to have flowing today.
Exactly. Okay.
Yeah.
So that and the way you do that is you escape that two-dimensional surface that we drive on, right?
Yeah, and then pray that you do it right.
Exactly. And so that's the thing is, like, you're praying that you do it right. Well, we can escape that two-dimensional surface by going underground instead of up top, right? And so what we can do...
Well, here particularly we can't, though.
What? And that I would argue that we can.
This is fun.
Absolutely. So, Elon Musk has a big, presentation, and I would say the view of him is, SpaceX and all that. Little known, he was, the creator of PayPal with some of his other friends. But anyway.
Oh, yes.
So he also
Yes,
has, he's also starting and has been working on a company called The Boring Company, which is a play on words because what it does
That's
is
fantastic.
it drills through the ground. It bores through the ground.
Of
So
course.
The Boring Company, yes. And so what he's basically...
Wow. Yeah.
Exactly. Yeah, he's a smart dude.
That's amazing.
So he's basically trying to... Not trying, he's making these tunnels that will be able to take cars down from street level into the tunnel and basically shoot them through these underground tunnels. And various companies and organizations have competed by building their own capsules of these things. And it's a slightly different whether you're in a car or whether you're actually in like a passenger tube. But basically these tunnels that can take cars underground at high speeds around 200 miles an hour and cover very long distances in a very small amount of time. And the problem with this, the upside to this as opposed to those flying cars is no matter how safe you make a flying... I believe Elon Musk made this point himself. No matter how safe you make a flying car, there's still a 2-ton object hanging above your head, right? And that's always going to be a safety concern. And so when you build these tunnels, you while you have the tunnel and the mass, the tunnel above you, you eliminate that risk of a large object falling on you due to either driver error or some malfunction and having a car fall out of the sky.
Right.
And so that's a much more practical application of the flying car, I think, and that technological innovation, like you were mentioning earlier, Israel. I think that's where people are looking for flying cars, which they're not really looking for flying cars. They're looking for cars that have the ability to escape the street traffic. And the way you do that is you add that third dimension. And we think about it up, in the sky because that's what we look at. But, there's a third dimension down, too, into the earth.
Well, I mean, we've had underground tunnels and stuff like this work, but the question is, how can they bore through the limestone, the porous limestone, and build such massive objects that won't crush the kind of limestone structures under the cities and cause sinkholes above, stuff like this? I mean, have they considered specifically Miami?
So that's
because
a great point. Because right now he's working in California, I believe, Los Angeles area.
Yeah, you could make all kinds of layers underground.
Right,
there.
and so that's you definitely bring up a good point in that innovation wise, and it's not right now. It doesn't have the ability to be a ubiquitous system and be everywhere. But you can still, drawing back to that idea of that's a challenge, right? And we need to figure out a way to match that challenge. And we can't say, oh, that's a problem, and like, okay, this isn't going to work because that looks like a problem that this can't solve.
Yeah,
once you do that, you've consigned to no improvement,
Right. Yeah, it'd be nice to see if this boring company can do something exciting with Miami's porous underground.
Yeah. Here's the thing,
Excuse
though.
pun.
Like, regardless of what was that? Whether we get self-driving or flying cars within our lifetimes, are we ever going to let it get to the point where public transportation, one of the biggest industries in the country, is affected by this rapid pace of advancing technology?
Well, if we could actually figure something out in either of these two cases, whether flying or underground, of course. Are you kidding me? I mentioned the flying car thing in passing as an impractical kind of joke because a self-driving flying device would require that we've mastered the kind of forces that you would experience in aviation, which, if as any physicist or engineer or scientist in general who study these things knows, we haven't solved these things fully, and it's almost impossible to solve them for all the situations that you encounter.
Right.
Whereas stuff like you are on the ground and moving through air is significantly easier.
We do have self-piloting drones, though. That's something that we have. It's not an unachievable.
I'm not
thing,
saying it's unachievable. It's just
not even,
it's not
I don't think
something
it's
that
even, it's not even that. It's not that far. It's just that you have to incorporate so many other things into like takeoff and landing and logistical aspects.
Yeah.
I think the actual flying itself is. This might sound weird, but the actual flying itself is kind of trivial. It's the everything around it that's the problem. You need to have takeoff points and landing points, and you need to have safety regulations. We know how to fly things. We've known how to fly things since Orville and Wilbur.
well, people can do it. Yes,
Right.
we can do it,
Mhm.
and obviously, yeah, we have drones that fly, but a swarm of these things, like such a high population of just having. Imagine like a drone swarm. If you have just, let's say, a couple
Or your Amazon
thousand
being
of them.
delivered
Yeah, or like an Amazon situation where you actually have these drones and stuff flying so close to each other. I'd love to see this happen. I just where I was gonna take this, I wanted to mention on something I read from one of our listeners here. So they discussed a different kind of technology. So they were bringing up the concept of terraforming. And this is something I wanted to bring up.
Mm-hmm.
So his question is, while he agrees, right, that basically destroying any possible biodome that might exist on Mars, right, would be unethical and just a bad idea, what about a biodome situation where we quarantine, terraform, and colonize a portion of Mars? So that's something I think that is more down the alley that you guys have been concerned with recently at SEDS.
Sure. Yeah, and I think that that's a much, as that listener said, a much more logical and reasonable approach.
Right.
And I don't mean to discredit Mr. Musk's idea of that, but having that area of having ourselves contained is the key, right? We can't. It's irresponsible of us to just run rampant, and having, I think he pulled an arbitrary value of like 100 square feet or something. That value can be whatever.
acres.
It's whatever we need. But the idea being that that we need to make sure we keep ourselves. We're reining in ourselves, and we're not destroying that biodome, as you mentioned. Yeah.
Yeah, it'd be tough. I thought it was interesting that you brought up this, what is it called, the Boring Company,
Mhm.
right?
Yeah.
Elon Musk's Boring Company. Because, from what I've looked into, if you're gonna somehow survive on Mars, you'd have to be underground, is what I've heard. Can you tell me something about that?
Sure. So that's one of the, I guess, theories or methods of escaping the problems or the hazards of Mars, is that, like I mentioned earlier, temperature fluctuations and UV radiation. Both of those can be, I don't want to say well mitigated, but can be, especially UV radiation, can be dealt with well by being underground. Ultraviolet light, very small wavelength, right? So that it doesn't penetrate very deep. It's very it gets reflected and absorbed very easily. So
Right.
even a little bit underground, you get away from that UV radiation. And a little bit underground, you get away from that surface temperature fluctuation as well, and you're kind of more in tune with the actual planet and the temperature of the rock. And so that's where like that I think that theory comes in, is that's one method to be able to do that. I think what it's drawing back to what that listener mentioned of having a closed space where we have like a terraformed area, that does a similar thing. If you have that dome that's got a UV shield on it, and whatever you're making inside has the ability to produce heat of some kind, then you are golden just as much as you would be underground.
Yeah, and see, this is fun.
And by the way, guys, I just want to interject here. If you'd like to jump in or comment, please text in at 786-309-8861, 786-309-8861, or if you'd like to call in, just let us know. And, yeah. What were you guys saying?
Well, so with Mars, we had another listener that texted in and let us know that as clearly the core of Mars is dead. That seems like something that's obvious, I guess. But do we know anything about the core of Mars? It's kind of, I feel like it's just going to be kind of a floating cold rock. I would hope so, for what I'd like to say.
Gonna be perfectly honest, I haven't done a lot of research on Mars's geological state, but
me either.
But if that is the case, then you don't have a changing surface like you don't have the plate tectonics that are being moved by a magma center.
Which that would be a much better situation, I think, especially if we've progressed solar technology enough that just with all the stuff bombarding the surface, you can have a couple of rays to energize your colony. And as we discussed at the very beginning of this show, that could be also one of the major advances that we get as a bonus of exploring space, is that we can have maybe a really a better crack at solar energy, and I think we can all use some of that.
And we just got a text from the same individual who said that the Mars core is dead. No geomagnetic fields.
Well, that explains it there. If there are no magnetic fields coming out of it, you can be pretty sure there's nothing going on in that core. And that's good. Wouldn't that bode well for this concept of colonization? Wouldn't you think? Less
if
change,
the core is
less
dead?
Variables. Yeah, of course.
Not necessarily.
No,
I think
so.
that the what you just said, less variables. The thing about life is that it needs spontaneity, right? It needs a changing system. It needs something. It needs kind of a continuous set of trial and error, right?
Okay.
It needs to be.
The individual just texted us again. Sorry. The atmosphere will get ionized and lost.
So, yeah. So what it needs is that it needs something that, as conditions change, it has the ability to grow and adapt. And so, it's hard to say. I hesitate to put a hard, fast rule on whether a dead core is, whether a dead core is good or not. But I think it just comes with its anything. It comes with its own set of pros and cons.
What do you think about the ionization of the atmosphere?
Well, that's just obvious because you're closer
Right.
to the sun, and you don't have an actual atmosphere to protect you from. It just doesn't have the kind of mass in its atmosphere to deal with the amount of energy coming from the sun straight to Mars. That one.
Right. I think at this point that any talk of colonization is a stretch, because first off, we have to figure out how are we going to get a person over there and guarantee that they make it out of there alive. And I don't think we're really at that point yet.
Well, we may be in this room, but let's be honest. That's
Right.
That doesn't mean that going for it and trying to figure that out isn't useful.
Yeah, absolutely. And I
And
think,
that's-
the big dazzling idea is colonization, right? We want to move our people there. And I think, people kind of skim over that, let's find some other life, because they write it off, right? They're like, well, we haven't found, there's no other people out there, so there's probably no other life.
There's gonna be nothing.
But, one of NASA's missions that just ended, Cassini's space probe, big head nod to them, because it spent 13 years around Saturn. And
those are some beautiful images.
Absolutely.
That was amazing.
And it sent us a lot of information. And one of Saturn's moons Enceladus, was thought to just be an ice moon. But after further investigation and discovery, they found that it's actually got major water geysers shooting water out of the bottom of the moon.
It's amazing.
And what this leads to is that they found a massive subsurface ocean in this moon. And they're not sure whether it spans the whole planet yet or not. The whole moon or not. They don't think it does. But it's basically this massive ocean. And that ocean is thought to be in contact with calcites at the core of this moon. And geological chemistry speaking wise, that is very exciting. Those are the building blocks of life. Is water in contact with a certain type of rock is basically what you need. And that's how ours was thought to start. And so when you look at that, it's all of a sudden like this crazy mind-bending whoa.
Yeah, that there's a real possibility we could find organisms that have been growing there.
Absolutely, and that we can't rule out life. We can't rule out life in our solar system yet. We haven't even fully discovered it. And while it's not humanoid, again, we have to consider them. We have to consider it a possibility and respect that. And that's why Cassini was ended the way it was, putting it into the atmosphere so that it didn't potentially land on. Or disrupt
that one little spot that had an organism growing that could have said
exactly that one spot, but that that probe landing on a moon, the components or whatever, the certain chemicals and stuff that's on that probe, you just don't want you don't want any risk.
It's going to contaminate the fact that it would give people arguing against that life having been there before the probe touching it an argument in the first place to say that So I think. Yeah,
Cassini just flies into Saturn and falls and hits someone on the head.
No, it's just if you have a satellite that goes in there, then somebody could say that later on that the organisms that you're finding there are a result of bacteria that was somehow preserved on Cassini all the way there.
That's another great point.
One of those stretches, but it's still something that somebody would use, and they can't use it because we didn't do that. Awesome. This has been such a fantastic time, Sean.
Right.
Thank you.
Thank you,
joining
Sean.
us. Sean
Absolutely.
is once again from SEDS, the Students for Exploration and Development of Space. You are the president of this club.
Yes, sir.
And man, I had a great time.
Thank you, everyone, for joining us. My name is Israel.
I'm Andy, and you want to say anything on passing here?
I'm
Yeah.
Sean. It's been great to have some time here at the Monkey House. I appreciate you guys having me.
Swinging through the veins.
And any of my Miami listeners, feel free to you can shoot me a text at 414-793-7385. That's my personal number if you want to get involved in the club at all. 414-793-7385. And you can text me or call me, and we'll be happy to sit down and pull you in and get some work done.
That's a sweet deal. All right, Sean.
All right. Thank you guys for joining us.
This has been another episode of the Monkey House.
And we'll join you again next week for whatever the heck we're going to do.
Absolutely. And keep it locked.
Good night.
Bye, FSU.